Welcome to this video about Chimera. Chimera is an impairment emulator which allows you to emulate the impairments of real-world Ethernet networks inside your own lab. In this video, I will demonstrate the Chimera flow filters which are used to map incoming packets to a maximum of 8 flows per port. Every flow can subsequently be individually impaired. For this demonstration, I'll be using the Xena live demo system, which is connected to the internet and available to you, so you can try it out for yourself at any time you want. If you're not familiar with the Xena live demo, I will encourage you to watch the step-by-step video guide on how to connect to this system. Chimera supports 5 speeds, going from 10G to 100G. For this demonstration, Chimera is configured for 25G and connected to a local traffic generator, as shown in this slide. In 25G configuration, both devices have 8 ports. You will see that internally in Chimera the ports are subdivided into port pairs, between which Chimera is acting as a bump in the wire. We will be using the Chimera port pair, including port 0 and port 4. Loki and Chimera are directly connected, so that everything transmitted on Loki port 0 will pass through Chimera port 0 and then be forwarded to Chimera port 4 and transmitted back to Loki port 4. In this setup, I will use Loki traffic generator to generate 8 streams of Ethernet packets, which will then be mapped onto 8 different Chimera flows using the flow filters. We will use the Chimera flow statistics to verify that the Loki streams have in fact been mapped to different flows. Next, let's take a closer look at the Xena live demo system. This is the Valkyrie manager connected to the Xena live demo system. In module number 2, we have a Chimera impairment emulator, and in module number 0, we have a Loki traffic generator. Expanding the modules, we can see that both have 8 ports configured for 25G operation. Further, we can see the port pairs in Chimera. For the purpose of this demonstration, I'll reserve the ports, first in Chimera, and then in Loki. Further, to see the statistics, I need to click the Used option for all the reserved ports. Finally, as previously explained, I have created 8 streams on the Loki port. Each of the streams is configured for 12.5% wire load, amounting to a total of 100% wire load for all streams. If I start the traffic and take a closer look at the Chimera statistics, I can see that all the incoming traffic is now mapped to the default flow. This is because none of the flow filters have been enabled. So, now let's take a closer look at the input filtering. Looking into Chimera, we can see that Chimera implements 7 prioritized flow filters on each port. If a packet matches a filter, it's mapped to the corresponding flow, which can be impaired independently of other flows. Any packet not matching one of the dedicated flow filters will be mapped to the port default flow shown here at the bottom. The flow filters consist of 6 subfilters which are used in combination to filter incoming packets. This slide illustrates the 8 streams configured in Loki, while the Chimera subfilters are indicated here at the top. In the following, I'll explain how we can combine the subfilters to map each of the streams to Chimera flows. Notice that only the encapsulation used for filtering is shown. So, let's go to stream number 1. From the encapsulation, we can see that we can configure the L2 subfilter to filter on the DMAC, and we can use the L2 plus subfilter to filter on a VLAN ID of 111. So now let's go to Chimera to define our first flow. The first thing we need to do is to enable impairments on the port. We do that by selecting the port and moving to the port configuration and click Enable Impairments. Secondly, we expand the port and select the flow we want to configure. We move to the filter config, select the L2 subfilter and click the destination MAC address. Here we can now type in the destination MAC address of stream number 1. In the same way, we can select the L2 plus subfilter and configure a single VLAN, and then type in the VLAN ID of stream number 1 equal to 111. Enable and apply to start filtering. Notice how the little funnel indicates active subfilters and the little green icon indicate that the flow is now active. To see the effects of this filter, we move to the flow statistics on Chimera and we can see that a total of 37.5% of the traffic is now mapped to this flow. This is equal to 3 streams. So why are 3 streams now mapped to this flow? To understand this, let's go back to the locus streams. Looking at the encapsulation, we can see that the DMAC and the VLAN ID of the first 3 streams are in fact identical, which is why the first flow filter will match all packets from these streams. To illustrate how flow filters in Chimera are prioritized, I will configure a second flow filter to match stream number 2. This flow filter will use the L2 plus subfilter to match the VLAN ID, the L3 subfilter to match the IPv4 destination address, and the L4 subfilter to match the TCP destination port. Back in Valkyrie Manager, I'll select flow number 2, go to the filter config, and configure the L2 plus subfilter for a single VLAN with a VLAN ID of 111. I'll also configure the L3 subfilter for IPv4 with a destination address of 1234. Finally, I'll set the L4 subfilter to TCP with a destination port of 111, so the filter is now matching the encapsulation of stream number 2. Enable and apply to start filtering, and we'll move to the global statistics to see that stream number 2 is now mapped to flow number 2, indicated by 12.5% of the traffic now moving through flow number 2. We can see that streams number 1 and 3 are still mapped to flow number 1. So now, moving to stream number 3. Here, I'll use my L2 plus subfilter to match the VLAN. I'll configure the L3 subfilter to match the IPv6 source address, and finally, I'll use my layer 4 subfilter to match the UDP source port. To configure this, again, I select my flow, move to the filter config, and configure a single VLAN, IPv6 source address, and finally the UDP source port of 202 to match stream number 3. Enable, apply, and move to the statistics to verify that stream number 3 is now mapped to flow number 3. Stream number 4 is a double tag frame with an outer VLAN ID of 111. So why does Chimera not match this stream to flow number 1 with a similar VLAN ID? The reason is that when the L2 plus subfilter is configured for a single VLAN, it will assume that this VLAN is a C tag and verify the correct ether type. When configured for a double VLAN, it will assume that the outer tag is an S tag and the inner tag is a C tag, again verifying the correct ether types. To filter stream number 4, I'll use the L2 plus subfilter to match the VLANs and the L3 subfilter to match the IPv4 destination address. In Valkyrie Manager, I'll select the filter configuration of flow number 4. I'll configure the L2 plus subfilter for a double VLAN and configure the L3 subfilter for an IPv4 destination address. Enable, apply, and again verify that stream number 4 was correctly mapped to flow number 4. Now let's take a closer look at Chimera's ability to filter based on MPLS. Stream number 5 has an MPLS label which we can match using the L2 plus subfilter. Inside there's an IPv4 payload, and I will use the L3 subfilter to match the source IP. Selecting the filter config of flow 5, I can configure the L2 plus subfilter for MPLS and type in the label value. And then I can configure the L3 subfilter for IPv4 and type in the source IP. Enable and apply, and look at the statistics to confirm that stream number 5 was mapped to flow number 5. Stream number 6 has 2 MPLS labels. The L2 plus subfilter only supports a single label, so we will use this to match the outer label. Chimera supports a very flexible any filter, which allows you to map 6 consecutive bytes at a configurable offset. We will use the any filter to match the 20 bits of the label value in the inner MPLS label at position 18. Inside the filter configuration of flow number 6, I'll configure the L2 plus subfilter to match the outer MPLS label. Then I will use the Any filter at byte offset 18 to match the inner MPLS label. To match this, I need to set a mask of 20 bits, and I need to configure the label value. I can now enable and apply and verify from the global statistics that 12.5% of the traffic equal to stream number 6 is mapped to flow number 6. Xena Valkyrie traffic generators can insert a Xena test payload into their packets for different kinds of statistic. The test payload contains an ID which can be used for flow filtering inside Chimera when used in combination with Valkyrie traffic generators. This allows very simple filtering with no need to specify the actual packet encapsulation. Stream number 7 has been defined with a test payload ID of 100, which I will use for filtering in the Xena proprietary subfilter. So now I'm ready to configure the final filter for flow number 7. I'll do that by configuring the Xena subfilter and entering a test payload ID of 100 equal to stream number 7. Enable, apply, and now looking at my stream statistics, I can see that I have exactly 7 flow filters mapping 7 streams to 7 flows. Finally, I have a single stream not matching any of the filters mapped to the default flow. Thank you for watching.